So we're off to our last session before lunch, which is our next sponsored session, and we're returning to the theme of data. And this is in praise of the data engineer. And I'd like to introduce the presenter is Matt Holzapfel, who's the head of corporate strategy at Tamr. Matt, over to you.
Yeah, thank you, and good afternoon, everyone. I know that I am standing between you and lunch, and so the stakes are high here. But I think the topic is one that is really important in today's climate, where a lot of organizations are trying to get more value out of their data, as we've been talking about today. And so, as Lachlan mentioned, I'm Matt Holzapfel, and I work for Tamr. We're a data mastering software company based in the Boston area. And today, the focus is going to be on how to really get more value out of your data through best practices around data engineering. So why is this topic so pressing today? Digital transformation is a buzzword that seems like it just won't go away, and for good reason. The customer experience is becoming more and more digital, and more dollars are being spent in investments in order to help that customer journey. And these investments are being spent in a couple of different ways. I think a lot of the focus over the past 15, 20 years has been around software and really helping more companies use software internally as well as externally. But particularly over the past a handful of years, we've seen that data is becoming much more top of mind, and we would argue that the importance of good data is even higher than the importance of good software and good software practices, and that is because, or one of the reasons for that is when software breaks and something doesn't work, you're just not able to access it. You get a 404. This example from Salesforce: trail not found, but you can't do anything else. When data breaks, the consequences can be much worse. This is so it's a kind of exaggerated example, but the reality here is that within enterprises, data is often wrong or bad or dirty all the time, and people might not know it. They have dashboards that they're using to drive mission critical decisions where the data is stale or incomplete or inaccurate. And so the stakes for getting data right are extremely high and continuing to grow as more of the customer experience, the employee experience turns digital. As a personal example of the importance of good data engineering practices and having good high quality data, earlier in my career, I worked at Dell, where my team was responsible for building predictive models in order to estimate the manufacturing cost of laptops and other products that we were buying from suppliers. And that stage in my career included a stint in Taipei, where I wasn't only responsible for executing on the modeling and the analytics, but also had to take those models and then defend them with suppliers. And I remember one negotiation in particular. It was a climate similar to today, where chip capacity was extremely constrained, and we had to really negotiate for every last penny that we were trying to save to pass on to our customers. We were in a conference room that had seating for about 4 people, and there were 6 of us crammed in there, and this was Taipei, so the weather was particularly humid and hot, and it wasn't much more comfortable in the room. The reason for the meeting was because we had, through our predictive modeling, we had said the cost of this laptop is $200. We think we should only pay $200 because we did all of this advanced math, used all of this historical data, and we think it costs $200. The supplier, they'd quoted us $210, and when you have a product that sells tens of millions of units, those $10 and that gap between the two means everything. And so we're in the meeting. I plug in my laptop into the projector in the room, share my PowerPoint, begin explaining the modeling that I had done and all of the advanced math that we had been using in order to predict the cost and how we got to $200. In doing that, I got nothing but blank stares. The pushback from the suppliers was just show us the data. We want to see the inputs. Model's great. It's wonderful that you're using advanced math, but show us the data. And after a bunch of back and forth, we started to look at the data, and they said, looking at this, a lot of the data that you're using in your models, we think is garbage. It's data that is based on when semiconductors were in ample supply, and that's just not today's environment. And so in essence, what they were saying is that our data sucked, and that no matter how good the model was going to be, unless we had better data, it was going to be difficult for them to trust us and ultimately to meet us where we wanted to get to. And this is a kind of challenge that we see organizations running into more and more every day as the hype and the buzz around AI/ML continues to grow. The sexy part is around predictive modeling and what can we predict, what can we forecast, how can we improve that? And too many organizations are tempted to put that advanced modeling and all of the great statistical work that data scientists and analysts can do before they actually have the clean data to fuel those models with things that is actionable and that people are actually going to trust. And that in supplier negotiations, for example, people are actually going to listen to and be able to drive business outcomes for. And so how do we solve this problem? How do we get from these large enterprises where many of us, when we join a large enterprise, we inherit all of this data debt of just this mass of on-prem cloud data that's on people's laptops, and we're trying to make sense of that and use that for these practical business applications, like figuring out how much something costs or figuring out who our best customers are. One of the first steps on the journey where we see customers who are really best in class, and some of the government agencies that we work with who we think have done just a really tremendous job with data. One of the kind of first things they do is there's this mindset shift. It's away from thinking purely in terms of what is the infrastructure I need and data lakes and data warehouses, but actually starting to think about data as a product. The infrastructure is important and necessary, but we have a lot of great infrastructure now, particularly with the cloud. Scalability isn't the problem anymore. It's the quality of the data, and can people use that and get access to it in such a way that's going to be powerful. And so kind of one of the first mindset changes is really thinking about how do we put our data into the context of how people are using it, organize it into these key entities around parts, customers, products, so that those really core data assets are nicely structured for people to consume. Within that, how you go from that kind of wasteland of massive varied sources of data spread throughout the enterprise to clean, actionable insights that the business is using in order to help their company grow or save money or reduce risk. In the middle is really the data engineer, and in many organizations, this is the chief data officer that's really responsible for driving the agenda. But I think kind of beyond thinking about data in terms of products organized by these key entities, the other piece of that is building out strong data engineering capabilities where they can go from raw source to curated data assets that consumers, analysts, data scientists can then just plug and play downstream, but really building out that supply chain to make an efficient process from raw data through to curation and consumption. And so for organizations that are looking to go down this path, some of the key principles that we've seen that work particularly well, especially in organizations that are going through larger scale transformations are, number one, thinking in terms of agile and continuous. This has become standard practice within software companies and throughout a lot of parts of organizations, but hasn't kind of fully made its way into data teams and data organizations. There's often this fear of, well, what happens when I update my data? Am I going to get a different answer than the one that I was expecting? And then I'm going to have to go to my boss or my peer and tell them that the previous conclusion was wrong. There's a big part of this is just kind of breaking free from the concerns and fears of what happens when the data is continuously changing and the answers that I'm getting are changing. Really need to establish the mindset and the environment that's going to happen, and we are going to kind of increment our way to a better state. The other key piece of this to highlight is around open and best of breed. One of the things that we found with recruiting and retaining really strong data engineers is that they want to work with the best tools. They want to work with the right tool for the job. And one of the ways that you enable this is by having an open and best of breed infrastructure that gives you a lot of flexibility in terms of how you actually build out those data products and be able to scale them up and down as the business evolves. But perhaps more importantly than that, by giving your people the tools that they want to use and that they find enjoyable, you can solve this talent problem, which is often at the core of a lot of data challenges for organizations. And so really modernizing the stack around open and best of breed, as well as cloud, helps not only give you that agility, but also helps you just build a stronger data engineering organization. And then the last piece of this is, as you're just building out those data products, really thinking in terms of quality over quantity. One of the things that we've seen really evolve within the market over the past year, particularly within the AI community, is that people are saying it's not about how much data you have, it's about the quality of data that you have that's important. And so keeping that front and center as you're going on this journey. And then as you're embarking on this journey and starting to build out the stack, having a framework or a guidepost for how you want to build out that modern data engineering ecosystem is really important. The way that we see the world is, on one hand, you have your raw sources, your raw catalog, your raw source governance, privacy, and policy. And then on the right side, you have your curated data, and being able to build the bridge by using the capabilities and skill sets of that data engineering organization can help you build a really efficient flow from, here are all of my raw sources, and then here's the clean curated stuff that I want people consuming within their analytical and data science environments. One of the things that I think is really encouraging, particularly for large complex enterprises, is that there are companies that are demonstrating how you can really solve this problem at scale. I'll give a couple of examples of a couple of our favorite customers who we think have done a really nice job of being just very pragmatic about having a clear business problem and business impact in mind, and then working backwards towards a solution that will enable them to solve that problem at scale. I think a good example of this is at Santander, where the problem and challenge that they faced is they had a limited view of customers, which would ultimately slow down the lending decisions. And so when they peeled back the onion on what is adding cycle time to lending decisions, what they found is the data that they had about customers wasn't nicely and cleanly organized. And so that created a lot of challenges with just manual attempts or manual processes needed in order to validate customers or check sanctions lists or develop rules in order to try to solve this process. Working in partnership with them, what we've been able to develop using Tamr as well as their core data engineering skills is this automated pipeline that enables that customer onboarding experience to be extremely fluid and cut the lending process time in half. And so this is a great example of when you have really great data engineering laying the foundation. It's happening behind the scenes, but it's very visible to the customer. They're getting answers. They're getting benefits from working with Santander in a much faster time. And so the impact that just cleaning up the pipes, cleaning up the plumbing behind the scenes can be pretty significant. Another example of this is the work that we've done with the Department of Homeland Security, where they started with the fundamental question of how can we start performing real-time assessments on passengers as passengers are traveling, and we need to check them against risk criterias and watch lists. How can we do that in an automated and scalable way? One of the things that has been really effective about the work with them is this very agile and iterative approach. They started with, well, let's just see if we can get a machine learning model that does this very accurately. We proved that out, and then we moved on to the data engineering piece of let's automate this and prove that we could build out that pipeline that does this end to end. And then next, let's scale it up. Let's prove that we could do this at the scale of tens, hundreds of millions of passengers. And then finally, let's show that we can do this not just in the US, but for our sister nations who need this technology. And so rather than boiling the ocean and saying, hey, we need everything on day one, they broke down the problem into chunks, but always had this clear line of sight to what they were trying to solve for, this automated process so that they could perform this screening very quickly and ensure that travelers were safe and properly screened. And so just in closing here, in the takeaway from what we've seen with these two case studies and what we've seen just work very well in practice is work backwards from the outcome. There are a lot of impactful ways to use data, but often the biggest challenge is just prioritizing one and getting started. And so once you have that one outcome in mind, then you can start to think about, well, what data product do I need to build? Is that a customer data product, a supplier data product? Start to build that, stitching together software, services, and data. And then from there, start to deliver that outcome. And then once you've delivered that first outcome, what we've seen is our customers are able to very quickly go from 1 to 10 to dozens. As an anecdote, GSK, with the work that we did, helping them build a data product around their clinical trial data, they said the number of use cases that their data scientists were able to solve within a year went from 10 to hundreds, and the number of questions that people asked about the data grew exponentially with that. And so building this data-driven culture really starts with getting that data engineering piece right, get some insights, and then the questions will start flowing. And so to wrap here, if there is interest in learning more about Tamr or hearing more from us about some of the ways that our customers are applying data engineering best practices at scale, we're very keen to meet and share that expertise. And so please reach out and feel free to sign up for a demo and see how the product works. But kind of more importantly, we are here to help share some of these insights, because we are very passionate about helping enterprises really start to get more value out of their data. We really feel like the data revolution is in the very early innings. And so please reach out as you have questions, and we'd love to partner with you on your journey.